You are watching the 5.10 video lesson on completing the square. What we're going to be doing today in this video is practicing this concept of completing the square. Now, it's going to be very helpful for us, as with many of the factoring questions that we've done in the quadratic functions unit, which is going to come next. So right now, we're just developing a skill that's going to help us in the future and hopefully make our lives a little bit easier down the road. Question number 1 has 4 parts, A, B, C, and D, and it's asking us to simplify each one of these polynomial expressions. Let's go ahead and do that. The first thing that we need to keep in mind is that anytime we have something squared, so x plus 3 all squared, I want you to rewrite this as x plus 3 all times x plus 3. Now, many of us are getting very familiar and comfortable with working with our polynomials, and we can jump from here to the next step very easily. So I'm not going to do that on the first one, but maybe C and D will talk about it. Most of us are using either the double distributing, so we're going to take the x and multiply that times the x plus 3. And then we'll take the plus 3 of the first binomial and multiply that all times x plus 3. So again, what we did was took this x times x plus 3 and the 3 times the x plus 3. Next, we distribute and group together our like terms, if any. So we have x squared plus 3x plus 3x plus 9. I went through that pretty fast, but this is just because it should be reviewed for all of us. If I group these two together, we end up getting the final answer of, I'm just going to write this off to the side because I'm running out of space, x squared plus 6x plus 9. Okay, let's take a look now at part B. Expand x plus 7 all times x plus 7. Let's show the box method for those of us who like this strategy. Again, some of you are getting away from showing a lot of this work and using what we know about the polynomials to help us. So this becomes x squared, 7x, 49. So if we group our like terms together, we end up with x squared, 7x, and 7x become 14x plus 49. Moving on to part C. First step, expand. Okay, go ahead, double distribute. Okay, here's the answer that we should have gotten for part C, after you either multiplied through using the box method or you showed the strategy that we did in example A. Try D on your own. Okay, so here is the answer to D. The one thing that I want everyone to make sure that they're staying away from, maybe I'll write this in red because this is bad. I do not want you to have anything that looks like this as your final answer, or anything that looks like this as your final answer. If you're getting something that looks like either of these two things, it's because you are forgetting to actually double distribute. You're only choosing to multiply 2 of the terms when we should be multiplying 4 times actually. So these are wrong. Be very careful not to make that mistake. Now moving on to question number 2, we have A, B, C, and D below. And what we need to do is we have to factor all of them. Now I am going to check and actually use my shortcut method. I need to find 2 numbers that multiply to 16 and add to 8. So what 2 numbers multiply to 16 and add to 8? That would be 4 and 4. So remember to get the x squared. That would be x times x. And since I found 4, we're going to place those in there. Well, that's kind of cool. We could always rewrite that as x plus 4 all squared if we really wanted to. Okay, move on to part B. Let's see the same thing. Two numbers that multiply to 25 but add to 10. Well, here's my skeleton template. What two numbers multiply to 25 and add to 10? Well, 5 and 5. So in order to get this x squared, we need x times x. And because that 10x is positive, both of these 5's will be positive. Oh, same cool thing is happening. Instead of writing x plus 5, I could also write this as x plus 5 squared because there's two of them being multiplied times one another. Here we have C. Let's do the same thing here, only being careful now, this middle term is negative. So we need two numbers that multiply to 81 but combine to be negative 18. Okay, well we know that this is x and this is x. So what two numbers multiply to 81 but add to negative 18? Well, my first thought was 9 times 9, but we do have to be careful because they're not positive, they have a negative sum. So a negative 9 and a negative 9 would add to that negative 18. Again, the same cool thing is happening. I can rewrite this as x minus 9 all squared. Let's do the last one. Try this one on your own, actually. Pause the video, go ahead and try this. Here we have our answer to part D. I'm hoping that you're finding the same cool thing is happening. We are finding the same exact number times itself that's giving us this value and adds to this one. So we're able to write all of our final answers as this nice pretty math package. Now part E asks us to summarize what exactly is happening basically in parts A, B, C, and D. If we notice our numbers here, this is a perfect square in all of my trinomials. And the really cool part about that being a perfect square is that this middle term is the sum of those two numbers. So when we're factoring these trinomials, the two numbers that we get, what I like to call the magic numbers, they are always the same. And because they're the same, it allows us to write each of the trinomials in a nice factored form at the end. Moving on to question number 3, we are playing a very exciting math game where I'm going to give you the first two terms of a perfect square trinomial and you have to find the constant. So we need to figure out the number that goes there. Now there's some space for work, but some of us might not need to show that. So remember, this middle term here was some number added to itself. So one way that you can think about this is take half of it, right? Because 12 cut in half, or 12 divided by 2, is 6. But that's not the number that went there. We got that number by doing 6 times 6. So example A would have a 36 there. Let's try the same thing with B. So with B, our middle term was 14, so some number plus itself was 14. Well, half of 14 is 7. But that's not what would go here. It was really the 7 times 7. So 7 times 7 is 49. Okay, C. Let's take half of 20 again. That's negative 10, because negative 10 plus negative 10 is negative 20. However, we also need to make sure that we multiply negative 10 times negative 10. That's actually a positive 100. Negative times a negative is a positive. Okay, last one. Our middle term is a negative 6, and half of that is a negative 3, because negative 3 plus negative 3 would give me this negative 6. And lastly, we need that same number times itself to be here. This is working backwards from what we did in exercise 2, or example number 2. So now we've worked kind of backwards. We've found that missing number that we're looking for. Okay, now for the finale. We are going to take what we just did and we are going to kick it up one more notch. You just completed the square, but now what we need to do is apply it to different types of polynomials. So instead of playing the guessing game, it looks like we're actually given a number here and we have to complete the square to make our polynomial written in a certain form. We call it the vertex form of a quadratic. We're not quite there yet, but we are going to complete the square for all these parts below in question number 4. One of the main things that's different between questions 3 and 4 is that there actually is now a number in this spot down below here. Now, this is not going to change the process, but it is going to have an impact on maybe our final answer. So I'm actually going to just ignore the plus 17. In fact, I'm going to write that almost off to the side as an afterthought, but something that I can't forget. And then I'm also going to bring down the x squared plus 6x. And now we're going to play the same game that we played before. So what number can I put here that will, in essence, complete the square? So I want this piece to look something like this. Okay, so I'm going to write that underneath. Of course, to get the x squared, this would be x and x. And then we want two of the same number to add to 6. So what two of the same numbers add to 6? Well, those two numbers are 3 and 3, because 3, or positive 3 plus positive 3, is 6. So the piece that's missing is whatever 3 times 3 is, which is that plus 9. Now, because in part 3 we actually were changing values of expressions, and we're not allowed to do that with our polynomials down below, if I'm going to decide to add 9 to my entire my entire polynomial, I also have to subtract 9, because a positive 9 and a negative 9 is actually 0, meaning I never really changed its value. So just to break this down, this piece here became this. What we haven't talked about yet is what the negative 9 and the positive 17 become. Well, that's simple. We're just going to combine those together. And write it down below as a positive 8. Now, there's another way that I can write the x plus 3 times x plus 3. We can write that as x plus 3 squared, and then also bring down the plus 8. This is how we complete the square. For part B, let's change this plus 10x to a minus 10x. So let's write this as x squared minus 10x plus 105. Okay, let's begin. Remember that plus 105 is something that we're going to use towards the end of the problem. We're not going to use it just yet. What we're trying to do is we need to take this x squared minus 10x plus or minus something and turn it into 2 of the same binomial times itself. Okay, so the only way that we will get an x squared is if we multiply x times x. And the only way that we are going to get a minus 10 in the middle is if we add 2 of the same number together. And those two numbers happen to be a negative 5 and a negative 5. So thinking backwards, we're missing this piece here. What is a negative 5 times a negative 5? That actually is a positive 25. So if I add a 25, I need to be careful because I can't just change the value. If I add 25, I also need to subtract it because 25 minus 25 is 0, and 0 won't change anything, at least not when it's added. Now I'm left with the minus 25 plus 105. So I can group those together and rewrite that as plus 80. And my last and final step would be to group together the x minus 5 squared plus 80.